Hello viewers, welcome to today's lecture on 8051 serial data communication. We have already discussed the need for serial data communication. Let us very quickly recap what we discussed earlier. As I mentioned, the first reason for serial data communication is to reduce the cost of cabling. If you use parallel communication, then you have to use a cable with a number of wires. On the other hand, in case of serial data communication, a pair of cable and a ground line is sufficient, and as a result the cost of cabling is much less in serial data communication. And also, since you are taking only one pair of wire carrying signals, it will minimize the effect of noise. On the other hand, whenever you take several wires together, there is crosstalk and noise increases. So serial data communication minimizes the effect of noise. And also there exist many communication media which are inherently serial in nature. As you know, the telephone line, satellite link, all these private links are serial in nature. So availability of suitable communication media also forces to use serial data communication. Moreover, there are many devices which are inherently serial in nature, as we have already explained. And particularly in the context of handheld battery operated small devices, small connector is also very important. If it is a parallel communication, you will require a big connector. On the other hand, in case of serial communication, a small connector with few pins will serve the purpose, which can be easily fitted in small equipment. But in the context of microcontrollers, the need for serial communication is more stringent, because more important because of the current need for distributed computing. As you know, nowadays the computing is taking place in a distributed manner, where a large number of computers, including embedded systems, are taking part. So to facilitate distributed computing, it is necessary to have serial data communication. Moreover, the microcontrollers are presently used in realizing sensor networks. So whenever you have a sensor network with large number of devices communicating with each other, then you require serial communication. So sensor networking is another reason to have serial mode of communication. So it's no wonder that 8051 will provide such a facility, built-in facility. In fact, the 8051 designer has provided a built-in serial communication facility. Let's see what are the key features of this 8051 serial interface. First of all, it facilitates full duplex communication. Full duplex communication. That means you may recall that we have already discussed the different types of serial data transfer possible. One is simplex mode of communication, where data transfer takes place only in one direction, so maybe from microcontroller to some IO device, or it can be full duplex, where simultaneously two-way communication is possible. As you can see, this is an IO device, this is a microcomputer, so data transfer is taking place from microcomputer to the IO device and from IO device to the microcontroller simultaneously. Obviously, this will require two lines available in parallel. Two separate lines should be available for full duplex communication. However, there are situations where only one line is available for bidirectional communication, and as we shall see, 8051 also facilitates this half duplex communication. So you can see here, using the same line you can communicate microcomputer to the I/O and I/O to the microcomputer. Obviously, you cannot do the communication simultaneously, and you have to use suitable protocol so that the communication can be done properly in both direction, one after the other. Now, so this is one important feature. So it supports full duplex as well as half duplex communication. Then comes the second feature is it is receive buffered. By that I mean the serial circuitry has been provided with two buffers. One is for communication between the microprocessor and one for serially taking data from the serial line. That means after receiving one byte of data, still you can receive the second byte. However, in such a case, the reading from the first buffer has to take place before the second byte of data which is coming serially is complete. Otherwise, one byte of data will be lost. That means reading data from the serial receive buffer and receiving serial data can take place simultaneously up to one byte because of this receive buffer facility that is provided in 8051. Then you have got special purpose register. Special function register is provided, which is known as SBUF. This is the mnemonic that is being used, SBuffer. Although a single register is available for communication, but physically you have two such buffers inside. When you transmit, when transmitting, then the data goes to the transmit line directly to the transmit buffer, and whenever you are receiving, then it goes to the receive buffer. So data goes to, when transmitting, data goes to transmit buffer. Similarly, whenever you are receiving, then the data goes to a separate receive buffer which is available within the processor. Although the address is same, mnemonic is same, physically inside the device you have got two such buffers, one for transmitting, one for receiving, and that facilitates you full duplex communication. You can keep on sending and receiving simultaneously. Then you have got 4 different modes of operation. Four different modes of operation to facilitate or to satisfy the need for a wide range of applications. For different applications, the need is different. In some case, the data transfer rate should be small. In some case, the data transfer rate should be high, and also the number of bits can be 8-bit or 9-bit. So to accommodate variation of data transfer or to satisfy the need for different requirements, 4 different modes of operation has been provided, and we shall explain these modes in detail one after the other. Then, as I told, in 4 different modes, it supports wide range of baud rates. Wide range of baud rates. As we shall see, if the clock frequency is 12 megahertz, which is the maximum clock frequency that is allowed in case of your 8051, the typical 8051 processor, whenever you use that, the baud rate can vary from, say, 1 megabits per second to maybe 110 bits per second. So such a wide range of baud rate is available, bits per second. So this is the baud rate range. So you can see it will definitely satisfy the need for high speed data communication and also low speed data communication depending on the application. So it supports wide range of applications. Then it has been provided with special function registers to facilitate which is programming. That means you have got SCON, which stands for serial control, and it is used to define the operating modes, and some control functions. I we shall discuss in detail about the function of this SCON register. So with the help of this special function register SCON, you can do the programming, you can configure the serial interface in different modes of operation, and you can also control various operation. Apart from this SCON register, serial control register, there is another register that is known as PCON, which is commonly used for power control. However, one bit of PCON is also used in the context of serial data communication, particularly to control the baud rate, as we shall discuss in detail later. So, in a nutshell, these are the typical features of 8051 serial interface. Let us now see how you can program this SCON register to configure the serial interface in different modes of operation. This SCON register, which is known as serial port control register, it is one of the special function registers which can be accessed as any other registers, a special function register, and it has got 8 bits, 0 to 7, and here are the different bits starting from 0 to 7 shown here. These two bits, SM0 and SM1, bits 6 and 7, these two bits are used to decide the mode of operation. That means, as I told, it can be configured in 4 different modes. Whenever these two bits are 00, the device acts in serial mode, and which is typically known as shift register mode of operation. And as we shall see, the baud rate in this case, the frequency of the oscillator by 12. That means if you use 12 megahertz, the 12 megahertz clock frequency, your baud rate will be 1 megabits per second. So in this particular mode, so in this mode you can communicate at a high rate. Then the second mode, when these two bits are 0, 1, that means this bit is 0, this bit is 1, then it can be used as a 8-bit UART. That means this is the typical use of the serial interface as a universal asynchronous receive and transmit. So whenever you use the device as a universal asynchronous receive and transmit, then it uses this particular mode, and in this case the data is 8-bit, and baud rate in this case will be variable, as we shall discuss what will be the different baud rates that you can achieve, that we shall explain, and it is programmable, so you can have different baud rates, standard baud rates in this particular mode. Then this 10, that mode 2, although I am writing 9-bit UART and 11 mode 3, this is also 9-bit UART. These two modes are used typically for multiprocessor communication, and we shall see how the communication can take place either at a little higher speed, the frequency of oscillation divided by 64 or 32, or it can be variable. So you have 4 such modes of operation, where you can use it as a shift register, you can use it as a universal asynchronous receive transmit device, or you can use it for multiprocessor applications. And this bit, SM2 bit, facilitates the use of the device for multiprocessor communication, and whenever you use this SM2 bit, we shall see this will enable the use of the device in multiprocessor communication mode, and later on we shall explain the use of this SM2 bit for using multiprocessor communication. We shall see how it can be done, how it can use it for multiprocessor communication. Then you have the REN bit, bit 4, this is receive enable bit. That means with the help of this bit, you can enable or disable receiving of data, and that means if this bit is set to 1, you can set it by bit set, that means bit manipulation instruction, and to enable receiving of data, or you can disable receiving of data by programming this particular bit. Then this TB8, transmitted bit 8, the 8 bit that you want to transmit, that is 0 to 7 is the normal 1 byte of data. Now 8 bit of data can be decided by the programmer. It can be parity bit, as we shall see. It can be used for parity bit, or also it can be used for multiprocessor communication. Later on we shall see how this bit can be used for communication in master slave mode, and this bit facilitates that. That means bit 8 which is stored here is transmitted as the 8 bit, and similarly RB8 is the 8 bit that is received while receiving data through the serial port, and it goes to this RB8 bit. Now we are left with 2 more bits, that is TI and RI. TI stands for transmit interrupt flag. That means this is used for interrupting the processor. Whenever one particular byte of data is transmitted, after the completion of the transfer of data, this interrupt is automatically set by hardware, and it can be reset by programming, or whenever the processor jumps to interrupt of the subroutine, automatically this bit is resetted. So it is set by hardware, resetted by programming, or by whenever you jump to interrupt of the subroutine. So this is used for this is essentially the transmit interrupt flag bit. Similarly, you have the RI flag bit, the receive interrupt flag bit. The receive interrupt flag bit is used in the receive mode of data transfer. Whenever you are receiving data, after you have received 1 byte of data or 9 bit of data, whenever you are using the other modes of operation, as we shall see, you can receive 8 bit or 9 bit of data. After the completion of the data receipt, after whenever the 9 or 8 bit of data is received, this flag bit is automatically set to 1, and it can interrupt the processor if this is not disabled by programming. And similarly, just like the transmit case, this bit can also be resetted by programming, or whenever the processor jumps to interrupts of the subroutine, automatically this RI bit is resetted. So you can see how SCON can be used for configuring the modes as well as perform some control. As I mentioned, 1 bit of that power control PCON register, special function register, power control register, bit 7 is known as S mode, serial mode, and in this this particular bit can be used for modify the baud rate. So this bit modifies serial baud rate modify bit. If this bit is set to 1, you will see the baud rate will be doubled, and whenever this bit is 0, baud rate is as programmed by other means, as we shall explain later. So this is the function of the various control registers for programming the device in different modes. Let us now look at the function of the mode 0 operation of the device, which is essentially shift register mode of operation. In this shift register mode of operation, you can use in half duplex mode. As I explained, you are using a single line for data communication. This is the case where this is being done. That means half duplex communication is done. You can see here RxD pin is used for both transmit and receive. That means at a time either you can transmit or you can receive. You cannot do both simultaneously because you have been provided with only 1 pin for communication of data. Then we will be asking what the TXD line is done. The TXD pin is used for generating the shift signal, which is also available outside for shifting data into some hardware, some discrete circuitry. So obviously this mode is not used for data communication with computers, because baud rate in this particular case is f oscillation by 12. So depending on the clock frequency, if the clock frequency is 12 megahertz, then the baud rate is 1 megabits per second, as I told. And obviously such a high data transfer rate is not possible in normal RS-232C, other standard serial communication modes. However, you can transfer data or shift data to some hardware device, and that is the application. So the application is, it is not used for data communication with computer, with other computers. However, you can use it to send data to some external device. For example, here is your 8051. So you can use some shift register externally, where you can shift data where the RxD pin is connected and TXD pin is used to shift data. So in this way you can store some, for example, it could be a device that can use it CD4094, where you can store large bits of data, and which can be serially shifted from 8051 using this RxD, and also that TXD pin used as the shift signal. And as you can see here, whenever you are receiving data, that data is whenever you are transmitting data in this case, then each byte is shifted out on the that S6P2. That means this is the state 6 and phase 2 of the clock. So on each of the trailing edge of this S6P2 phase, one character of one bit of data is shifted out. So in this way, 8 such bits are shifted in subsequent machine cycle. So in each machine cycle, as I have told, one bit of data is shifted out through the RxD pin. And this TXD clock, as you can see, is available, which remains high from state 3, high from state 6 to 2, and low for states 3 to 5. So this is acting as a clock or shifting of data to the outside world for synchronization. Similarly, whenever you are receiving data through the RxD line, you are shifting, as you can see here, this edge is used for reading data one after the other. And the shifting is done at the edge of S5P2, that means state 5 P2 phase, that is trailing edge of that phase 2 signal of state 5 shifting is done place. So just one clock cycle before this goes to high. So at that point, each bit of data is shifted through the same RxD line is shifted into the 8051. So in this way, you can shift 8 bit of data at a time, and as you can see, this can be used at a high speed of, say, a maximum speed is 1 megabits per second. So this mode is useful for communication with some discrete devices. But possibly the most widely used mode of operation will be the mode 1, which is the standard universal asynchronous receive transmit mode. And this allows 10-bit full duplex acts as a 10-bit full duplex receiver transmitter, and you can use one start bit. This is the start bit, and after this start bit, this is the idle state, and the synchronization takes place on the trailing edge of the start bit. And after that, the data, if it is 1, it remains high; if it is 0, it goes low for one baud, that means the 1 bit duration. For the entire duration, it remains high or low. And at the receiving end, in the middle, the shifting in of data take place in the middle of the clock period. As a result, since you are shifting data at the middle of the signal, this allows you to have small difference in clock frequency between the transmitter and receiver, and also because of glitch and other noises, the false data transmission is avoided because of this reading of data in the middle of the bit period. So this is how it is being done in case of this serial mode 1, and as I have told, you can use both transmit and receive in parallel, because in this case this microprocessor is provided with the TXD and RXD. Both lines are available for communication in serial mode. So full duplex mode of communication is possible in this case. And the baud rate that is possible in this case is programmable. You can have programmable baud rate, and timer 1, I have explained the operation of timer 1. Timer 1 is used for baud rate generation, and the frequency of the baud rate, usually timer 1 is used in mode 2, that is your auto load. In auto load mode, mode 2 is used, timer 1, for generating the baud rate, and as a result you can generate a wide range of baud rates with the help of this particular mode, with this help of this timer 1. And the baud rate can be calculated in this manner. Say f baud will be equal to 2 to the power s mod. This s mod bit is this particular bit, this bit 7 of pcon, as I told. That means whenever this bit is 0, then this is 1. On the other hand, if this bit is 1, then it is 2. That means baud rate is twice compared to if this bit is 0. And then we have got 32 in decimal, and this is multiplied by that frequency of oscillation by 12D into 256, since it is a 8-bit in mode 2, minus that TH1, that higher order bit of the timer that you program, that will be decided, and this will decide the baud rate. And you can find out the baud rate from this equation. Actually, baud rate will be 256 D minus 2 to the power 0 by 2 to the power that is mod by 32D into 11.0592, if this is the clock frequency, into 10 to the power 6 by 12 into say 9600 is the baud rate. So let's assume for a particular operation we want to make it 0, and we want to find out what will be the value that you have to program so that you get 9600 baud rate, and you will find that this is equal to 253. That means 0 FD. That will be the value that you have to load in the that higher order byte of that timer register of timer 1, and it has to be configured in mode 1. And by using this, the different frequencies that you can generate is shown in this diagram. As I have already explained, in mode 0, if the clock frequency is 12 megahertz, you can go for 1 megabits clock frequency. Mode 2 I shall explain later. So in case of mode 1, as you can see, depending on the clock frequency and what value is programmed in that TH1 register, these are the values which can be written into the THD registers, and depending on the clock frequencies, then the baud rates that you can generate can be generated is shown here. So you can see here the baud rate can vary from 62.5K to 110, and for different values and different clock frequencies, and also depending on the value of the S0 bit, you can see these are the various baud rates that you can generate with the help of the timer 1 in the programmable mode. So you can see the standard baud rates that is allowed in RS-232C starting from 19.2 to 110 is supported by this in this particular mode of operation. So this can be very easily used for data communication with any standard computer by using standard baud rate. And obviously you will be using it for data communication using some standard interface, that is your RS-232C, as I have already explained earlier. So here you see how 8051 can be interface connection can be achieved to interface with RS-232C. And as you know, the 8051 outputs are TTL compatible. Unfortunately, the RS-232C outputs are not TTL compatible, and as a result you have to use some level converters to do the conversion from TTL to RS-232C level and RS-232C level to TTL level, and this is being done with the help of a special chip known as MAX232. And MAX232 is very useful. You can just apply one plus 5 volt supply and few capacitors, usually the typical value is 22 microfarad. You require these capacitors C1, C2 and C3, and then you have got 4 such level converters. This is the TTL side. So on this side you can use TTL signal, on this side you can receive RS-232 signal. So here we have used it, just one pair has been used because you have got TXD and RXD coming out from 8051, and you can see these are the pin port 3.1 pin which is used as TXD and port 3.0 pin that is used as RXD, and these two lines are applied to the TTL side of MAX232, and it generates two signals which are RS-232C compatible here, 14 and 13, and these lines are going to a standard RS-232 interface. This is known as DB9. DB9 is a standard RS-232C interface, 9-pin connector, and this interface can be used for RS-232C communication. So this is the hardware that you require to implement RS-232 interface. Now let us see how the device can be programmed for transmitting data and also for receiving data. So here is a program to transmit data serially through that TXD line and in mode 1. So here we are writing a program to send a character. We are sending the character A continuously at baud rate of 4800, and baud rate has been, we shall program it as I explained. The baud rate is generated in this case by using the T1 timer in mode 2, that auto load version. So here the first instruction is using the timer 1 and mode 2. It is configuring timer 1 in mode 2 with the help of this instruction. Then you are loading that suitable value. -6 is essentially that FD, that to get 4800 you have to use that 4800 you have to use this value. Now FA, you have to write FA. So instead of writing FA in hex, you can write -6 also, that is equivalent to FA. So this configures this allows you to generate 4800 baud rate. This particular instruction loads the higher order byte of, that is the TH1 register. This is also a special function register. As I have explained in the last lecture, you can load it and configure it, for baud rate 4800. Then you are configuring the that serial control register in 8-bit data 1 stop bit, and you are enabling that REN signal, receive enabling. You are performing the receive enable signal. This is done with the help of this instruction. Then you are setting the TR1 bit, so you are starting the timer 1. So this starts timer 1. That means timer 1 now starts generating the clock, which is supplying the baud rate. And obviously you have to move the data character A to the buffer, S buffer, and it goes to the transmit buffer, and then it checks, as I told, that TI flag bit, that is the transmit interrupt flag bit, is used to check whether the data has been sent or not. When the character is sent, the TI flag bit is set. So that is being checked here. It is looping here till TI flag bit is 1. So whenever TI flag bit is 1, then you have to clear it so that it is ready. That means here letter A to be sent, and here this particular instruction, as I told, that wait for last bit. After the last bit has been transmitted, this bit will become 1, and this is, by clearing it, it makes it ready for the next character. So it clears TI to make ready for next character, and you are this way you are keep sending. So character A will be continuously sent by using this mode. Although I have explained this program where you are continuously monitoring the status of TI, instead of that you can also use in interrupt driven mode. After that character is transmitted, the TI, that transmit interrupt flag, will also interrupt the processor. That time you can do this operation. You can receive the character to some register. You can send it to some port, and so on. So instead of using writing the program in this mode, this way you can write it in interrupt driven mode. That is also possible. Now here I have explained, I have written a program to receive data serially. So the first part is identical. You are using that timer 1, mode 2, baud rate is 4800. Then this particular mode is, again, you are configuring it in transmitting data in 8-bit, 1 stop bit, and you are enabling REN. So same as the previous case. Now you are also setting that you are starting timer here, start timer to generate the baud rate for receiving. In this case you are receiving, and here you are checking. You can see here you are checking RI flag bit instead of TI flag bit, because you are in the receive mode. You keep on checking the RI flag bit, and RI flag bit will be set whenever the character is received. So here you are checking for data, and when the last bit is received, this will be set, and then you come out of this loop and transfer the data to the accumulator, and from that accumulator you can transfer it to port 1 where it can be connected to some display. So sends character to port 1, port A, V1 port 1, and you are now clearing the that receive interrupt flag bit to make ready for the next character. And then you loop back. So in this way you can keep on receiving a sequence of character one after the other, and you can send it to port 1 one after the other. So this is what is being done in this particular mode of operation. Now let us switch gear and consider the mode 2, which is a multiprocessor mode. Multiprocessor mode, in this particular mode you are sending 11 bits are transmitted. This is the main difference. Earlier what you did, you sent 10 bits, but here you are sending 11 bits of data. That means here in this particular case, this will be okay. This is your ideal state, and here is your start bit, and you have got, you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the usual way you will be able to send data 8 bits, but you have got 9th bit. Where this 9 bit goes and where from it comes. To understand that, you have to look at the you have to go back to our register. Here you see, as I mentioned, you have got two bits, TB8 and RB8. This TB8, when you are transmitting, this 8 bit, that means the bit 9, comes from this TB8. On the other hand, when you are receiving data, this after receiving this 8 bit goes to this RB8 flag. So these two bits take part in this mode 2 of operation. Now let us see what will be the baud rate in this particular case. In this particular case, the baud rate will be, in mode 2, baud rate will be F baud mode 2 will be equal to 2 to the power S mod, that particular bit of peak on register, then 64D into F OSC. So in this case, as you can see here, the baud rate is fixed. Even this is not variable. So we are using fixed baud rate. We are using fixed baud rate in this particular mode, and what will be the different rates, as you can see here. If you use 12 megahertz clock frequency and you have to divide by 64, then you get 375 kilobits per second. So 375 kilobits per second is pretty high, and this can be used for communication in this mode 2. And this is mainly used in multiprocessor mode. I shall explain this multiprocessor mode little later. But the rate of the way the communication takes place is same as the mode 1. The only difference is that in mode 1 you are sending 10 bits, and the start bit goes to that RB8, or when you are sending that your data is coming from 8-bit data is being sent, not the 9-bit. And here you are sending 9 bits of data. That's the key difference. However, we shall see the use of this bit, this particular bit, that SM2, makes a difference. I shall explain it after discussing the mode 3. Mode 3 is also standard UART, but it uses 11 bits of data and variable baud rate. That means in this case, baud rate can be same as baud rate is made available by using timer 1 in mode 2, or some other mode is also possible. Normally mode 2 is used in auto load mode. So you can get different baud rates same as the mode 1. That's why mode 1 and 3 are shown here. So all the modes which are possible to get in mode 1, you also get in mode 3. So in mode 3 you get variable modes, which is programmable by programming that timer 1, and on the other hand mode 2 uses the fixed baud rate, that is your 375 kilobits by when the clock frequency is 12 megahertz. That is the key difference. However, the main use of the that mode 2 and mode 3 is there is special provision for multiprocessor communication. And this is achieved with the help of that SM2 bit. I shall explain it here. Nowadays, as I told, you will be having a large number of sensors and they are networked. So you have a widespread deployment of sensor network where each of these devices will be communicating with each other. And as you know, nowadays Intel is trying to propagate that proactive computing, which is based on this kind of network. Lot of information will come from sensors, and automatically some of the actions will be taken without the interaction of the user. So to facilitate that, you must have large number of sensors communicate with each other, and this is being facilitated in this particular mode, this mode 3. Where you have the provision for multi-mode communication. How it is done, let me explain. So suppose you have got a large number of computers. Computer means sensors, where 8051 is being used as the processor. Now here you can use as in one of them can be master, and there can be a number of slaves. Now the ninth bit which is available in RB8 along with that SM2 bit can be used to send the address of the slaves with which masters wants to communicate. How it is done? Whenever SM2 is 1 and RB8 is 1, then all the slaves will be interrupted. All the slaves which receive that character, that address character, that means at this mode you are sending address. All the slaves receiving the having this RB8 bit 1 and SM2 bit 1 will be interrupted, and as a result they will check whether their address matches with the received address. That means the 8-bit data that you are sending in the first case is essentially the address. Now what the slaves do after receiving the address, all the slaves which are with which the master wants to communicate will retain that SM2 bit, will make this that slaves will disable the SM2 bit. All other slaves will disable this SM2 bit, and subsequently the master, whenever it will send data, the slaves will be ready to receive data, and only those slaves which were earlier selected will be receiving the master's data. All the slaves will ignore the data because for them now the RB8 bit is 0. That means whenever you are sending address, you make RB8 bit 1, and whenever you are sending data, you are making RB8 bit 0. So all the slaves which are not relevant, they keep SM2 bit is equal to 1. So they will not be interrupted when data byte is being sent. On the other hand, the slaves with this configuration SM2 bit is 0 will be ready to receive data, and at that time, since RB8 is 0, then the slaves will not be interrupted. However, the designated slaves will be ready to receive data, and it will receive the characters from the master. So in this way, that master-slave communication between a number of processors sensor devices can take place by using this mode 3 in this mode. And as I have told, whenever you have a large number of sensors, it may be necessary to transfer data at a very high rate. High rate means it can be as high as 375 kilobits per second. On the other hand, if you have a small number of sensors, then you can use a smaller baud rate in mode 3, and depending on the rate of communication, you can select the baud rate. So you can use the 8051 to implement an intelligent network of sensors in mode 2 and mode 3. So to summarize, in this lecture we have highlighted the built-in 8051, a built-in serial interface that is provided in 8051, and we have explained how it operates in 4 different modes. And as we have seen, mode 0 is essentially used for communication with some discrete device. It can be a serial device. And in mode 1, normally it communicates with conventional computers maybe using RS-232C ports, and that at that time it uses the standard baud rates that is being used in RS-232C. On the other hand, mode 2 and mode 3 can be used to implement a network of sensors devices, or it can be used for multiprocessor communication in master-slave mode. So it's a very powerful serial interface, and we can see here within 2 decades back this type of feature was incorporated in 8051, and that's why still it is being widely used in implementing embedded systems. So we can conclude today's lecture. Thank you.